plus 0.4 squared equals little d squared. 0.09, 0.16, that's 0.25, and then square rooting both sides, I'm going to get 0.5 is d. So now this is 0.5, and we're trying to find the rate at which d is changing. And it should come up negative because that's getting smaller. Let's see if it does. Multiplying here, it's going to be a negative 100, so negative 30. This will be 0.8 minus 48 with the negative equals 2 times a half is 1. 1 times that is just, so we're going to have a negative 78. And if I do units, that is a distance of miles per hour. Okay, 3 down, 2 to go. So number 4. Okay, we've got a man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. When he is 10 feet from the light pole, at what rate is the length of his shadow changing? I don't know if you can reason through it, but if you walk away from a light, your shadow will get longer and longer the farther out you go. So your shadow is going to grow. So here we go. So drawing a picture, we've got the light pole. That is a constant 15 feet tall. It's not going to change. The light at the top shining. And we've got our 6 foot tall man. With his shadow on the ground. Okay, and that's created because of the light shining behind him. His body stops all of that light, creating the shadow. Alright, and if you look, this is right back to Algebra 1 with similar triangles. Again, we've got the 6 foot tall man. That's not going to change, so we can put those in there. Those are constants. What is going to change is his distance from the pole and the length of his shadow. The shadow will grow, and so will his distance from the pole if he continues to walk away from it. So our equation we're going to write is just similar proportions from similar triangles. So if I go height to shadow, I can go height to length along the ground. Or any way you want to do it. I could go height to height and then length to length. Doesn't matter. I'm going to go height to shadow. So that will be 6 over x. That proportion is going to have to equal, the height is 15. And this length, I'm going to have to add the two together, x plus y. We could jump right into derivative right here, but we'd have to do quotient rule here and quotient rule here. It's going to be a little bit easier for us if we do cross products and simplify this first, then jump into derivative. So, cross product says 15x is going to equal, and here when I do the cross product, I've got to distribute 6x plus 6y. And I see x's on both sides that can come together. Now I'm going to have a much easier equation to work with. Okay, so now we're ready for the rate equation. So that means this will be 9 times by this derivative with respect to time, dx dt, Derivative here is just going to be 6 times its rate derivative, dy dt with respect to time. And now all I need are one of the two rates. I don't even need the x or the y. So, the one rate I know is that the guy is walking away at 5 feet per second. So which of these is changing at 5 feet per second? It would be this one back here. As he walks, this distance is increasing. The shadow is growing on its own. We're trying to find that rate. So the dy dt is your 5 feet per second. So it's going to be 9 times dx dt equals 6 times the 5. And it is positive because that distance is going to increase as he walks away from the pole. That's 30. So we'll divide by 9. So dx dt equals 10/3, and that will be feet per second. Okay, one more together. Okay, we've got a man starts walking north at 4 feet per second from point P. 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 feet due east of P. At what rate are the people moving apart after 15 minutes? Okay, first I want you to pick up on a little red flag in here. I've got a time given in minutes, but both of my rates are in seconds, so we'll take care of that at the end. All right, so here's my point P. And the man is walking north at 4 feet per second. The woman, who's 500 feet due east, that's 500 feet, she is going to walk south after a 5-minute delay. And then the question becomes, how fast is the distance from them increasing? At what rate are they moving apart? So I am looking for how fast this line is growing. As both of these grow, so is that pink line going to grow? All right. So let's see. So we've got the man that's walking north. I'll use little m for man. I've got the woman walking south. I'll use a W for her distance. And then I need an equation that relates the man to the woman and this pink line. The first time I did this, it took me a little bit, but then I saw, if I go back over this way, that's going to maintain the 500 feet, and this distance here will equal whatever distance the woman has traveled, because everything's parallel there. Now I've got a nice big right triangle again, down here with the right angle here. So as the man and woman increase, so is that a pink line. So my equation then with Pythagorean theorem, let's see, and we'll call that pink one, gotta give it any letter we want here. Let's call it R for a rate. So my Pythagorean theorem is going to be this side of the triangle squared plus the 500 squared equals the R squared. So this side of the triangle is M plus W squared plus 500 squared equals R squared. And we are ready for derivative. So first thing here is I've got an outside inside, so chain rule, so the 2 comes down, times m plus w to the first, times the derivative inside, and I've got 2 derivatives in there, so I need parentheses. The derivative of m is 1, times dm dt, the man's rate with respect to time, plus derivative of w is 1, times by its rate with respect to time, dw dt, plus the derivative of 2500 is going to be 0. And then derivative here is 2r times by its rate, dr dt. Just got that on there. Okay, now we substitute. And what I know is the man's rate, he's walking north at 4 feet per second, so dm dt is 4, and it is positive because that's going to grow that distance of m. dw dt, the woman is walking at 5 feet per second. And then what I know is the time is 15 minutes. I need to be able to find out m, w, and r at 15 minutes. So, again, what I pointed out earlier is that I know that these people are moving 4 feet every second and 5 feet every second. So I need to know this time in seconds. So each minute 60 seconds. That gives me 900 seconds here. So the man is traveling 4 feet every second. So that means his distance is 4 times 900. For each second, he's traveling 4 feet. So he will be 3,600 feet from that point. Remember now the woman, she left 5 minutes after him. So her walking time is only going to be 10 minutes. Which means she would have been walking for 600 seconds. So her distance, for every second she walks, she's traveled 5 feet per second. That'll be 5 times 600. So she will have 3,000 feet traveled. And now I can do Pythagorean theorem to get that distance between them. So that will be 3,600 squared plus 3,000 squared equals that r squared. And if you do Pythagorean theorem here and square root and everything, you get about 6,618.9 feet. And now we're ready to plug everything in. So it will be 2. The man was 3,600. The woman was 3,000. Timesing by 1, I don't need that. The rate of the man was 4. Plus the rate of the woman was 5. Zero's gone. 2 times 6618.9 times dr dt. Okay, so dividing by 2 will cancel those. So I will have 6,600 times 9 equals 6618.9 dr dt. So I've got to divide. Okay, dividing, and I get an answer of, kind of ran out of room there, 8.97. And that will be feet per second. Okay, you get to try on that worksheet 15, 16, 18, 19, 20, 21, and 27.